Okay, so today's experiment was one that it was very simple, it just used water bottles. So I'm going to tell you guys a little bit about what the experiment is and how you do it and what happened when I did it and show you my results. So first of all, basically, as I said, the experiment was very simple, and actually all that you needed were water bottles and, a freezer. So you were just supposed to take a few sealed, unopened water bottles, just plastic ones, and freeze them for 2 hours and 45 minutes is what was done in the instructional video that we watched. And then when you take them out, they're still liquid, but when you tap them on the counter or pour it out or anything, it'll instantly freeze, or pour it into another glass and drop ice in it, and you can see it kind of freeze. And if you pour it out, it'll make peaks, it'll freeze as it is poured out, and you make kind of an instant slushy like that. So that's what the experiment was supposed to look like. But mine unfortunately did not work, and I'll show you my water bottles. I just pulled these out of the freezer. I have a third one as well, and this is what they looked like when I got them out. I don't know how well you can tell, but they're not liquid. They are frozen. So I tried still, it's not 100% frozen, there's a little bit of liquid left, so I tried with this one, just seeing if it would do the peak, like when you pour it out to instantly freeze. That did not work. So my experiment went wrong, but as I said, it was very simple. So the only different thing that I did was I actually froze mine for more like 3 hours instead of 2 hours and 45 minutes. So I think that was my only issue, because as I said, my water bottles were unopened and sealed still, so they weren't unpure or anything like that. So I think that the difference was really just my time went a little over the 2 hour and 45 minute mark. And honestly, I just didn't really realize the importance of that exact amount of time. So I would try it again and try it, as I said, at the 2 hour 45 minute mark and see if that made the experiment go a little differently. But as for why it happens, it's actually called supercooling. And this is a very interesting little concept, actually. But basically, you can freeze things to be, the temperature of the water bottles when you pull them out is below freezing. It's called supercooling. And so when you pull the water bottles out, they're still liquid, but the temperature is actually below freezing point. And it basically just needs something to kind of start the freezing process. And I found a website that talks a little bit about it that was pretty interesting, and also mentions a process called nucleation. And which is basically what happens, it encourages the molecules in the liquid to form a crystal-like nucleus onto which the others can then latch, and just kind of start off the freezing process in the supercooled water. So that's why it happens. It's a pretty common, not common I suppose, but it's an experiment that's not much of a secret. I also found a lot of similar experiments, but there were many that used rock salt and a few other a few other supplies to do the experiment. There was one that used just a bowl filled with ice and rock salt and leaving the water bottles in it like that, and then then that instant freezes when you tap it on the counter, and you can watch it instantly freeze the water bottle. So that would be an interesting one to try, but this one was cool because it only used just water bottles. But like I said, mine didn't work. I think it's just a timing issue, because I don't really see any other discrepancies in my method in the way that I did the experiment. But it is because the liquid is considered supercooled, which I didn't actually honestly know was possible. So I think it's really cool that you can freeze a liquid below a freezing temperature, but it's not frozen. yet, if that makes sense. It hasn't changed states, so it hasn't gone from a liquid to a solid yet, but it has changed enough temperature-wise.